Now let us see the reference signal that are present in NB-IoT. NRS actually doesn't mean that it's a new reference signal. It actually stands for narrowband reference signal. Uh, i- interesting thing about this narrowband terminology according to 3GPP is 3GPP actually defined the term narrowband to indicate just 6 PRBs. So a EMTC carrier or CAT-M1 carrier is 6 PRBs, and by the time it came to NB-IoT, the terminology they didn't modify. It is still 6 PRBs as per 3GPP whenever they say narrowband. But in NB-IoT, the narrowband IoT, here we'll use just one PRB, that is 180 kilohertz. Just a confusion uh, in the name of narrowband. Just I want to share with you guys. So there are two NRS ports that are defined. Even though, as we have seen, it is UE is single RX operation mode, we can have two antenna ports. That is, both the antenna ports will have a single RF RX chain in the downlink. It is just for the reference purpose. There are two antenna ports that are given here. So this NRS, if you see, it is, in this pictorial representation here, it is present along with LTE CRS. One more thing to share with here is NB-IoT has three different operational modes. That is, it can operate in in-band mode or God-band mode or even standalone mode. In in-band mode, uh, it can lie on the same cell which LTE is camped on, and it can coexist with LTE together. So there will be presence of both LTE reference signals as well as NB or narrowband IoT reference signal as well in that particular downlink snapshot if we take of the PRBs. So uh, and in band and sorry in God band and normal standalone modes, we do not expect any LTE CRs or LTE reference signals present in the downlink. There will be just a NB-IoT reference signal that will be present. And this NB-IoT NRS signals, if you see, they are located at last two symbols of a slot, uh, just besides the LTE CRS, as we have been seeing here. This is the end of a slot, and it is present just at the last two slots, whereas LTE CRS can present even the first slot. Physical cell ID, it is same as legacy. If same NRS and CRS port mapping is used, same PCID is used for both LTE and legacy. And if there are if they are mapped to different cell IDs, uh, NRS and CRS are different. That is, depending upon the sector it is operating. We have seen that one particular cell can be broken down into three different sectors, and each sector will have a different cell ID. It is possible that NRS will have a different cell ID and LTE can have a different cell ID as well in the same cell. So if both the cells are different, then NRS and CRS are different. If both are same, then NRS and CRS will have some port mapping, and it's a table that is given in 3GPP specifications. And when it comes to NRS power offset, there is no power offset option given. And if we are using one antenna port, there is no power offset between LTE, CRS, and NRS. If you are using two antennas, and there is power offset is actually greater than it is higher than original data. I mean, if PDCCH data or PDSCH data, uh, it is uh, for NRS it is 3 dB higher. I mean, the reference signal will have 3 dB higher than NRS and than the PDCCH and other data channels. And uh, the center of LTE CRS sequence is used as NRS sequence for all the PRBs. Control signals. Let us see this control signals are referencing. I mean, uh, the synchronization signals, that is PSS and SSS, that is primary synchronization signal and secondary synchronization signals. We know that in LTE the synchronization signal spans in center 6 PRBs. Since we have only one PRB, it will span only one PRB in NB-IoT case. The periodicity is N-PSS is transmitted on subframe 5 of every radio frame, and whereas SSS is transmitted on subframe 9 of every alternate radio frame. It is not transmitted on all the radio frames. Transmission locations, since it is transmitted in subframe 5 on every radio frame, and SSS is transmitted at SF9 at every alternate radio frame, we cannot transmit in 6 PRBs, in middle 6 PRBs anymore, because there is a presence of uh, PBCH in the locations, as well as we can even expect the PSS and SSS sometimes in that location of LTE. N-PSS and N-SSS, it's usually present in last 11 OFDM symbols of the entire PRB of since we have only one PRB to span across the entire PRB. When coming to raster offset, uh, I mean, raster offset is the terminology utilized during cell search procedure. So if let's say suppose if LTE is freshly starting and it doesn't have any history with it, it just want to camp onto any particular LTE cell and it is freshly boot up. What it does is it goes to the starting LTE band that it has been configured in its database, and it goes and searches for the PSSI and SSS. This is the procedure that I'm saying in legacy. Uh, it goes and searches the PSS and SSS, and if it could find, okay, it then goes and proceed with the reading of MIB. But if it could not find, what it do is it uh, shifts its center frequency by raster offset that is configured here in LTE legacy. It is 100 kilohertz. That is, it just shifts its center frequency by 100 kilohertz and starts reading PSSS and SSS again and again. So this is the background behind raster offset there. So in here also in NB-IoT the raster offset is same. So it is maintained as 100 kilohertz. One key thing to note here is, if you see, one particular PRB spans around 180 kilohertz, whereas this PSS and SSS will be present in 180 kilohertz, whereas the raster offset is just moving by 100 and 100. Say suppose if it couldn't find the PSS and SSS in middle in the first PRB, and if it just shifts by 100 kilohertz, and if it tries to read, it is, since it is not a multiple of since raster offset is not a multiple of 180, it couldn't read there as well. So this indirectly gives us a hint that during in-band deployment, or normal any during in-band deployment, or standalone or broadband department deployment, this NB-IoT PRB cannot lie anywhere. It should lie in the frequencies such that it is multiple of raster offset. So that's what is defined here, PRB location for in-band operation. So PRB indices are already predefined, considering in the mind, okay, this is the place where I have to put my NB narrowband IoT carrier. And actually the number and location is a function of channel bandwidth. We know that LTE channel bandwidth can vary from 1.04 megahertz to 20 megahertz. So one key thing to note is one particular configuration of the bandwidth we cannot even deploy NB-IoT. That is, if we are operating our LTE cell with 1.04 megahertz, that is 6 PRBs, since the legacy PRB is legacy PSS and SSS spans entire 6 PRBs, in such scenarios we cannot even deploy our NB-IoT carrier or NB-IoT PRB in that particular LTE cell. Rest all are possible. So the number and location is actually a function of channel bandwidth. Uh, there is one more thing to share here is Not all NB-IoT carriers carry this PSS and SSS. Um, Only there is something called as anchor NB1 carrier and non-anchor NB1 carrier. Only this anchor NB1 carrier carries this PSS, SSS, and NRS, etc. So this anchor cannot lie on the, non-multiples of 180 non-multiple of 100 kilohertz. Whereas this non-anchor, it doesn't carry anything like PSS is a synchronizing signal, so it can lie there. The introduction of this anchor non-anchor variation is just because on anchor carriers we have all these SSS, PSS, NRS, and other things just in one BRB. It's a lot of control channel will have overhead. In order to have some new carrier where we can more concentrate on data, the concept of anchor and non-anchor can is introduced. So the non-anchor can lie anywhere in the LTE cell. There is no such restriction for non-anchor. We will see in detail what this anchor and non-anchor in further coming sessions of the course. So the channel structure indirectly is different for NB-IoT from legacy, and it is not backward compatible with LTE.